Welcome. Let's talk about the relational operators. In the last video, I talked a little bit more about the selection programming structure, and we came to the conclusion that what goes inside this purple diamond is a Boolean value that is the result of a Boolean operation. So the relational operator is a Boolean operator. So let's talk about those. The relational operators, they are a way to describe a relationship between two values. And so this type of relationship, you most likely have seen this before. I'm very sure that you've probably seen these values in the past, and you can see them here in the back on the screen, right? They are the equals to, not equals to, greater than, less than, greater than or equal to, and less than or equal to. When you have two values, you can describe them in relationship with one another, right? If I put person A and person B, and I say person A is 20 years old and person B is 20 years old, and I say, is person A the same as person B in terms of age? Then we could say, well, they are equal, right? So the relationship between the two is that they have something in common. There's something equal between the two, and that is their age. And so as you can see, the relationship, these relational operators, the relationship itself is a Boolean value. If I say, does this age equal this age? The result of that question is what? Is a true or false answer, or a yes or no, right? Is 20 equals to 20? Yeah, this is true. Is 19 equal to 20? No, that's false. So as you can see, as a continuation from the last video, we're following that same idea of where we're asking a question, and that question is a Boolean result, a yes or no. So all of these questions, all these 6 questions, or these six different operators, they always yield a result of true and false. So let's formally look at them and see how we apply them in code, right? So I have a little table here that I wrote. I don't know why it turned green. It wasn't green, but okay. Sorry, it turned green, but I have this table that is now a green table, and on the left, on the first column, I have the operators, right? Again, very basic stuff: equal, not equal, greater than, less than, greater than or equal to, less than or equal to. And the way we use them in math, if you remember, if we said this thing is equal to that, then we use the equal sign, and then we use the not equal, which was the equal sign with a little dash in between. And then we had the greater than, less than symbols, which is the 2 arrows. And then it's not a gang sign, 2 arrows. And then we have the greater than or equal to, so we put a little line underneath, and then less than or equal to. However, we have some of these symbols in our keyboard, right? We have the equals symbol, or the character in our keyboard, and then we also have the greater than or less than, but we do not have the equals to, or sorry, not equals to, and the greater than or equal or less than or equal. We don't have those. So in order to use them as part of our C++ code, then I'm going to write them here so you can see them. And I'm not going to use green, okay? I didn't choose green. So equals to would be what? It would actually be 2 equals. Why 2 equals? Can you think about it? No? Well, we already used the equals symbol, right? Where do we use the equals symbol? We use it when we're trying to assign a value to a variable, right? If I say int result equals 5, then I'm assigning the 5 to the variable result. So the symbol equals is already taken as a way to assign a value. So in order for us to use it as a relational operator, it has to be different. So what the programmer said, and this is something that is on almost, I would say, every programming language, is that they have said, okay, we're going to use 2 equal signs, and the 2 equal signs represents the relational operator, which asks the question, is this value equals to that one? So not equals to is actually a little exclamation mark in an equal sign. Exclamation mark, equal signs, all right? That's how we do not equal. So it's the opposite of equals. And then greater than, well, we do have that in our keyboard, and it doesn't have any conflict, so we'll do that. And then we have less than, which also doesn't have any conflict. And then greater than or equals to, well, that's easy, right? So it's going to be what? It's going to be a greater than or equals to. And then similarly, the less than, or equal to. So for us, just like we did with the arithmetic operators, where we had a value, we plus another value. So we had like 5 plus 3. We had the 5, we had the addition, and the 3. Well, similarly here, we can ask the question as, is 5 equals to 5? So we would have to write something like what? 5 equals 5. And that's a question. Is 5 equals to 5? And this will be what? The answer to this will be what? This will be true. Because 5 does equal 5. So this is the how it works, right? We put a value, the operator in the middle, and then the other value to the right. And this will give us the result. So now let's go and take a look at how these are done in code so you can see it. And then I'll talk about a few things that are important to have in mind when we work with this. Here we are in the same Learn C++ project that we've always been using. So let me clean some stuff up here. And let's just write some of these relational operators so you can see how they work. So I could do something like bool, right? Because we're going to hold the result in a Boolean variable. Again, it's a relational operator yields a Boolean value. So in here will be bool result is equal to, let's just say like we did in the board, we did 5 is equals to 5, right? So in here, we are asking the question, is 5 equals to 5? And this is indeed true. So true will go and be placed in result. And so in order for us to see this, let's put right here result, and I'm going to say result, and then it's going to print the result. Now remember, we talked on this in the previous video where we said that a Boolean value, when used as a number, it gets promoted, right? And a true is the same thing as saying the value number 1. And a false is the same thing as saying the value number 0. So in this case, result should be the value 1, right? Because we're printing a number, we're showing a number. So let's run this and see. So as you can see here, here we have result is equal to 1. Okay, and we can do many of these things, right? We can say is 5 greater than or equal to 5, and we run this, and of course that's also true. Now let's just do one where it's false so that you can see and you believe me, right? So here, 5 is 5 greater than 5. That's not true. That's false. So the result should be what? It should be a 0. So in here, I run this, and the result is 0, right? I'm not going to do the other ones. I feel like you can practice this. It's very straightforward, right? We can put any relational operation here where we have two numbers and we have an operator in between, and it yields a Boolean value. Now, what's interesting about this is that we are comparing values, right? Can you compare other kinds of values? Well, of course, right? Let's look at comparing Boolean values, right? So I can have is true equals to true. Does true equals true? That's true, right? Like yes equals yes. There's no like sometimes true equals true. So what is the result of asking the question, is true equals true? The result of that is also true. So we should get true out of this relational operation, and then that true goes into result. So let's do that. Let's run this actually. And here you see result is 1, right? So I can also say, well, is false equals to false? Well, false is equals to false, right? So that is true, right? Don't get confused with the trues and the false. Divide the question on its own, and then the result of that question is either true or false. So in here we have result is 1, because false is equals to false. What other kinds of data types have we talked about? Well, we talked about floats, right? I'm going to let you guys do those because it's the same thing we did earlier with numbers. 5 is equal to 5? Sure. So you can do 5.0 equals to 5.0. Try a lot of these, just to practice writing some code and stuff like that. But in here, what I want to do also is a character, right? So is the letter A equals to the letter A? What do you think? Are they equals? Let's see. Yeah, they are equals, right? Okay, that's good. Result is equal to true. What if I say, is A not equal to A? Well, I can also say that, right? That's going to be what? False. Okay, we expected that. What if I say, is A greater than A? How does that, what does that mean, right? How can a letter be greater than another letter? Well, let's see what happens first. We run this. The answer is false. Okay, A is not greater than A. I mean, in a way, we could think about it and say, okay, that makes sense. How can A be greater than itself? Makes no sense. What if I did this? Is B greater than A? Let's run it. True. B is bigger than A. Why? Well, remember, if you've been following along this video series, we talked about ASCII, right? And each of these characters have a numeric representation. And the numeric representation for B is the number 98. The numeric representation for A is 97. Is 98 greater than 97? This is true, right? So this is why it's true. So just like in the video where we talked about mixing data types and how you can do arithmetic with characters and booleans, it applies to here as well. So if you are new to this series, just watching this video, I'm going to leave a note. Check out the mixing data types for arithmetic operators, because all of the things that we talked about in that video also apply to here, which means I can ask the question, is true greater than A, right? We know this is going to be false because true has a numeric value of 1 and the letter A has a numeric value of 97. So if I run this, we get what? This is false, right? And to prove that I'm saying the right thing, I can say is true equals to 1. What do you think? That's going to be true, right? Result is true. So again, if you've been following along, remember, ASCII is how we convert a character into an integer. And then we said that we can mix data types with the arithmetic operators. Well, guess what? We can also mix data types with the relational operators. I forgot, so I had to cheat. But the relational operators, okay? And so as a last thing, before I wrap up this video, so the relational operators is an operator that yields a Boolean value. Therefore, as we talked about in our previous video, I said that a Boolean value, which is the result of a Boolean operation, like the relational operators, that can go into our purple diamond, as we talked in the selection programming structure video. And so in the next video, we're going to talk about another type of operator that can also go into our diamond, which helps us ask questions that have a yes or no answer. If you have a question, feel free to leave a comment below. If you like this video, if you found something useful out of it, and you don't mind, leave a like. If you're new to this channel, check out this video series, check out the channel, and if you like what you see, subscribe, be safe, and peace out.